Hey guys, what's up? It's Joe here, and today I'm going to be showing you how to make a very simple basic HTML front end for an Ethereum smart contract using JavaScript's Web3 library. The smart contract that I'm going to be using today is the one that I wrote in my previous video where we were coding up a simple Ethereum token. So today our simple front end is going to basically be a faucet for the token that we made where people can log on and simply claim some free tokens. Let's get started. So for the first step, we're going to open up the token contract that we wrote last time. And if you need a refresher or you don't know what I'm talking about, I'll have that video linked where I explained how to write your own ERC20 token contract and make your own Ethereum token basically. So I have that open here. Because we did all of that hard work before, we don't need to do it again. And in my previous video, I'd also covered actually deploying it to a test network to actually see the contract in action. Just to, refresh your memory, I'll do that again. We have this contract, and what I'm going to do is first, so I'm in the Remix IDE, which is one of the normal ones that people use for Solidity, Ethereum's programming language. And the first thing to do is we're going to compile our contract. Okay, so now it's compiled. We get a bunch of warnings, but that's fine. Now what we're going to do is we're going to go ahead and deploy it. So I need my MetaMask, and I'm going to switch to my favorite test network, the Goerli test network, because I have some Ethereum there from before. What we're going to do is in the environment tab, we're going to switch to injected Web3. And now you notice MetaMask opened up and it's asking me to connect with my account, and I'll connect with account 1, and we're going to deploy the contract token. So deploy, go ahead, and I'll need to pay some gas. That's fine. That's why we're on the test network. This is essentially free. If I were doing this on the real Ethereum mainnet, the process would be the same, but I'd have to spend actual money. So we can see that the contract is still deploying. So let's give it a second. Okay, there we go. Great. Now this contract is deployed. Now we need two things to make our Web3 front end. We need one, its contract address so that our front end knows which contract to access. And we need something else, which is called an ABI, an application binary interface, which is essentially a record of all the functions that our contract has inside it. And it tells basically Web3 how are we meant to interact with our smart contract. One of the great things about Remix is that it makes getting these two things very easy. So firstly, to get the contract address, you can just click this button, and now you've copied the contract address value. And to confirm it, you can go to the blockchain explorer for the Goerli testnet, and you can simply just put in the contract we copied. So let's put that in, and you see we can actually see our transaction. You can see that this is our new contract. So this is a contract which has balance 0 Ether, and it tracks the token TK. So that's proof that our deployment works successfully and we're actually on the Goerli testnet. And more importantly, that this contract address is what we want. Secondly, to get the ABI, if you go back to the compiler tab, and if you click ABI, you can copy that. And then now we can open up, I don't know, for example, the Notes app, and I can just paste what I copied. And you see that it's sort of this huge list essentially of the type of functions that I have in my smart contract, their arguments, what they return. The ABI is sort of the interface of my contract. It tells Web3 modules how to interact with it. So that's why we need this information. So for example, here you can see we have our function transfer from, which gives an output boolean. If we go into our contract and actually look at the transfer from function right here, you see that it returns a boolean, and it takes the parameters from, to, and value, which are of course written right here. So that way, we can confirm that the ABI we're getting, we can sanity check the ABI that Remix gave us. So now that we have the ABI and the contract address, we are ready to actually make our front end. To make our front end, the first thing that I'm going to do is I'm just going to make a new folder just to stay organized. So I've already have a directory called Ethereum Smart Contracts. You can of course make it wherever you want in your computer, but I'll just make a folder. And then if we go into my token, you see that there's nothing there. Our front end is going to rely on the Web3 libraries, that come with Node.js. To do this, you'll need to install Node.js. I'll put a link in the description. When you have Node.js, you need the npm package manager. So if I just type npm here in the terminal, you can see it gives me a list of commands. Now, what we're going to do is we need to start a new npm project. So we're going to say npm init and give it the Y flag as well. It's initiated a project for us. And if I do an ls now, we see we have this package.json file. We don't need to worry about it too much. And now what I'm going to do is I'm going to get the Web3 libraries that we'll need for our front end. So to do this, do npm I web3. And now we see that it's downloading. So I'm just going to let this happen. So it's done, and we see it's come up with a bunch of warnings, but it's found 0 vulnerabilities. So, I mean, everything's fine. So now if we do an ls, we can see we've got this other JSON file as well as this node modules folder. So if we go to node modules, and if we do an ls in here, you see there's a whole bunch of stuff, but most importantly for us, we have all of these Web3 libraries down here. And that's exactly what we'll want. We are now ready to make our front end. Okay, so now we can write the actual HTML file that'll contain our front end, as well as our JavaScript logic to actually connect to Web3. So I'm going to start off as you'd start. So this is going to be an HTML file. And since our first sort of front end is going to be very simple, I'm going to just put everything in one file just for ease so that you can see how everything plays together. For a more complicated project, you'd of course want to split off your scripts and your HTML and your CSS in separate files in order to keep everything organized. You're going to start off by saying that it's an HTML file. And I'm going to call this index.html. Now we're going to say, let's just add in a few more formalities. So each HTML document, of course, has a head as well as a body. So we're going to start off with the head. So let me just put the kind of ending tag as well, since I always forget those. We need to put in a reference to JavaScript files that contain the libraries that we need. So I'm just going to do that right now. Okay, so that's done. Before we move on, I'm also just going to give this page a title, and we can call it my token faucet. And so that's the head done for now. We can now move on to the body. And like I said, this is going to be really simple because I just want to convey the fundamental mechanics of how to connect to Web3. You can of course make the HTML as complicated as you'd like. So let's just give it a title, my token faucet. Since we deployed it on the Goerli test network, I'm going to just say my token Goerli faucet, just to remind us that this only works for Goerli. Then let's put a little break. Now we can have a small heading. So what I'm imagining is you have your title, which says my token faucet, a line, and then you're going to prompt the user by saying how many tokens do you want to claim, and then you're going to have a very simple input field with a submit button, and they'll put in a number, and then that's the amount of tokens that they'll get from your faucet. Here in this field, let's put enter amount of tokens to claim, colon. Now I'm going to put a form here because that's going to be the form that the people fill in to figure out how many tokens they want. So input, then let's say ID equals, let me just be lazy and call it input, type equals text, since they're going to be putting in text. And then you also want a submit button, so input type equals submit, value equals request. It's gonna be a submit button, and the text that it's going to have on the button is request. And this is going to be a form, so let me just put it in ID equals token claim. Okay, so that's our basic front end done, and before going on, we can just see sort of what it looks like. So if I go back to the terminal and I just see the files now, we have everything I got from npm before, but I also have my index.html file that I just made. And so I can just do open index.html, and you see it opens up in our Chrome the very simple front end that we designed. This is not on the internet yet. This is not on any server. This is just on my local machine, but this is what it looks like. So we have our title and our simple sort of prompt, and then you can type in whatever you want here. You can click request. It's not going to do anything because we haven't given it any logic, but that's what our front end is looking like. And the idea is you put in a number here, say 24, you click request, and then MetaMask up here should open up and prompt you to confirm that you want to do the transaction. For that, we need to actually connect this very simple front end we built to the blockchain, and this is where the Web3 libraries come in. Right, so now we can get on to actually making our front end talk to Web3. For this, we're going to need the script tag. So the first thing that we're going to do is we need to check for a Web3 provider. The way this happens is we say if type of Web3 is not equal to undefined, and then just for good measure, I'm going to get the console to log the accounts that are in this sort of Web3 instantiation. So essentially, if our connections are working properly and the MetaMask extension is injecting Web3 as expected, and it's interacting properly with the Web3 library, then the type of Web3 will not be undefined. So this if statement will trigger, and then we'll just basically make it clear that that's the Web3 that we're dealing with, the one from MetaMask, and to make sure we'll have a look at the accounts, and those accounts should match with the accounts you see on MetaMask. Otherwise, this is the sort of case that if you can't detect a Web3 provider, you might want to say maybe you should download MetaMask or whatever. This is where you'd essentially put a warning sign or something saying that there's something wrong with your Web3 connection. But I'm just going to cop out right now, and I'm going to say, you don't have MetaMask. So I'm just going to say your Web3 is just new. I'm going to look in the providers.http provider, and I'm just going to say, okay, just give me the Web3 of whatever local host you have. In this tutorial, we won't actually be thinking about this case at all. So this line doesn't really matter. And of course, if you were doing a better implementation, which was actually designed to be used by random users, you'd want to be more thoughtful about what you put here and handle exceptions properly. Okay, so now we have code that can talk to our Web3 provider. We want to now essentially be able to pinpoint our smart contract on the blockchain that we're trying to deal with. Remember that we had deployed our smart contract on the Goerli testnet because it's free. And so what we need is that contract address that we got before from Remix, as well as the ABI. So to do that, first I'm gonna make a new variable var address equals, and then I can just go to my notes, and we have this address which I can put there. So that's my contract address. Let me just make a label, contract address. And then I can say my variable contract is going to be equal to new web3.eth.contract. So the arguments to this function are going to be the ABI as well as the contract address. So we have that. We have the second one, it's address. So we can just put that there. The ABI was, of course, that big monstrosity that we saw before, this thing. So let's just go ahead and copy this. So there we go. I've copied it, and we have the contract now. I'm going to get the console to basically just log the contract just to make sure that everything executed fine and I didn't type in something wrong. So before moving forward, I just want to make sure that everything I've done so far is correct and that I can identify my contract correctly. So in order to do that, I'm going to need to open this file up. But remember, last time I just opened it using the openindex.html command, which just kind of renders the HTML. I needed to actually connect to some type of server. And the easiest way to do that is if I go back into the terminal and I just use the command http server. And what that does is that opens up an HTTP server locally on my machine from the folder that I call it from. And so I can basically open my index.html file on a local server. So if we go ahead and do that, it's made it, and I can see that it's available on this address. So let me copy that. Let me go back to Chrome. Let me just open this. So here it's opened it up. And now what I'm going to do, just to make sure that everything's working correctly behind the scenes, is I'm going to open up the inspect element. So here we see the HTML file I just built, and we're going to go to console, and you see now it's logged this other thing at line 255. And if we open that, we see that this is actually the contract it's logged, and we can see the address that we have from the contract address, which you can confirm on Etherscan, that this is the same address as the console output. So that's showing us that we're being able to talk to the Goerli blockchain contract properly. And remember, to do this, you need to have your MetaMask on the Goerli test network. Sometimes when you make changes to your HTML files locally, this HTTP server won't change your files unless you do like a hard reset of the browser. So when you have this console open, suppose for instance we didn't see this second console log statement, the first thing to try is to do the hard refresh. So to do that, when the console is open, you can right click on the refresh button and you can click empty cache and hard reload. And once you do that, if it wasn't there before, it should be there then. And if it's not there, even after the hard reload, that means something is wrong and you have to go back. So anyway, takeaway is that we seem to have put in the contract correctly. MetaMask isn't complaining that our contract is invalid. So that's good. And now we can actually go ahead and manipulate the functions that we wrote in the smart contract. Okay, so now we can talk with our contract. Let's actually see how to play around with the methods in the smart contract. And to do that, let's define a JavaScript function. It's going to be an async function, which means that since the operations we're doing change the state of the blockchain, this is just telling JavaScript that, look, that might take some time. This function might cause some time asynchronous behavior. So that's a flag giving a heads up for that. And what we can say is we can call this function claim, and you're going to claim a certain amount. So first we need to get the accounts that MetaMask has, and we do that like this. And so this line basically tells us, just because you can have multiple accounts in MetaMask, just give us the first one, the main account that the user is using. And finally, we want to actually run the transaction on the blockchain. So await, because this might take some time. And now we can actually call the method that we care about, which, as I said before, was transfer from. Now remember, we need the minter address, and the address that it's being sent to we already have because MetaMask tells us that, and the amount we have because the user tells us that. To get this minter address, the way I designed my contract was that it was just my default MetaMask address that was the minter address. So I can just go ahead and copy that. A nice little exercise at home is to not have to hard code this address, but for now I'm just going to hard code it. But at the same time, to not be a total barbarian, let me at least make a variable. So minter address equals, and then I'll just copy that address. And then I can just go ahead down here and put it in minter address from account. So the syntax for calling a method from the smart contract is contracts.methods.method name with any arguments. But you need this other bit as well, .send. When .send is used is when you send a transaction that alters the state of the blockchain. And whenever you alter the state of the blockchain, that requires some money. And so you're saying send that gas payment from the account here. If you're calling a function that just views the blockchain, then that doesn't cost any money. And so instead of .send, you can use .call. So now we have our method. To actually be able to use it when the form is submitted, we're going to need an event listener. So let's say constant form is equal to document dot get element by ID. And now I need the ID of the form, and I forgot what that was. It is token claim. Let me put that here. And now we can add the event listener form dot add event listener, and it's going to trigger on the submit, and the event is going to be given by this function. We're going to do a very basic response. We're just going to log the value in the console, and we're going to run our function claim with the form.input.value as well. The input is the amount of coins that they want, and the other arguments are sort of already given in upstairs. If you were actually making this for actual users, you'd want to put in other stuff such as handling errors. So for example, what happens if the user tries to claim more coins than there are in circulation? You'd want error messages like that. So that's an extension for you to try. There's one more line that I forgot to put, and that is to go here, and we need to add event.prevent default. And that basically ensures that the default response never happens, and that when the submit button is clicked, instead what we've said in here happens. So now we're ready to actually go ahead and test. Since our contract is deployed on the Goerli chain, you want to go into MetaMask and you want to make sure that you are on the Goerli test networks. One thing that you'll see right now that I can't see my token. If you've seen my previous video on how to make your own ERC20 token, the solution is the same. You just need to import it into MetaMask, and you can do it by simply inputting the contract address from before. I'll just get it from Etherscan since we have it open right now. Import the token, and you see the token symbol automatically comes up. We see that I already have a balance of 100 tokens. This is just a detail for my own smart contract. Your implementation might be different, but in my smart contract, this account was listed as the minter of the currency, and it started out with 100 tokens. If I just claim tokens from the faucet, it won't really make any difference because I'll claim them for myself, so they'll just come back to me and I won't see any change in the balance. So if you've been following along this tutorial with my smart contract, what you'll need to do to test it properly is you're going to want to go ahead and use a different account, and I've made a new account called Test over here, and that's very easy in MetaMask. You just click create account. So I'll switch over to Test, and let me do the same thing and import the token here as well. Great. And now we are actually ready to go ahead and try request some tokens. So I'm going to close this, and I'm going to ask for 25 tokens, and you see MetaMask opened up. It's asking, do we want to connect with the account? Yep, that's fine. So now you see that the actual transaction comes up, and it gives us a gas fee that continually updates, and it's updating because we're connected to Goerli, which, it's a test network, but it's still a public test network. It fluctuates depending on the network activity. Let's just go ahead and accept that because we have plenty of Ethereum. And if we go back here, we see that this is pending. Let's just give it some time. And there it's done. And if you see, now we've successfully claimed 25 tokens. So our faucet worked as expected. And if I switch to my other account, you'll see that this reduced to 75. So another thing that you could add to this logic is to continually replenish the minting address if you want it to be a non-constant supply currency. But that's just one of many things that you could try play around with, throughout this tutorial. I've highlighted other points where you could do your own experiments and kind of extend on the basic framework that I've presented here. So that mostly does it. In this video, we basically learned how to use the Web3.js library to turn an Ethereum smart contract into a very simple browser application, your first Web3 application essentially. In this video, we used my ERC20 token contract, but the same ideas apply to almost any smart contract that you'll write in Ethereum. For any smart contract, you'll need a way to first make your front end talk to the Web3 provider. And then for any smart contract that you've deployed, you'll need a way to talk to it using this command. And of course, you'll need to know what the ABI is as well as the contract address in order to be able to access the smart contract that you deployed. And then finally, whatever smart contract you write will have functions that you'll want to call when people interact with your front end. And this syntax over here sort of gives the general flavor of how to do that. So the principles in this video would apply to basically any smart contract that you want to come up with a front end for. And of course, you can also make your front ends look nicer with CSS. Thank you very much for watching. If this video was helpful, please leave a like and subscribe, and I'll see you later.